where do normal lab values come from? How do we know if your lab test is in the normal range? And if it's on the high end of normal, or it's on the low end of normal, or it's exactly in the middle of normal, which one's better? Is there a better? Is that the right way to think about lab tests? Should we use lab tests for promoting optimal health? I think the answer is no, but I'm going to try and make my case here by starting by discussing where these normal ranges even come from and how to interpret blood work in that context. So, briefly, where normal values come from is we find people who have no known medical problems and we test 1,000 of them or 10,000 of them or however many. And their lab values fall on a bell curve. So that bell curve shows you where the average is, and it shows you where the 95th and 99th percentiles are. And basically we pick, we say, well, if you are inside of the 95th percentile or the 99th percentile in some cases, then you are in normal range. If you are outside of those, then your lab test is abnormal. Now, the interesting challenge here is that even in the sample group where we are establishing this normal, some people are on the far edge of that bell curve. Some people are abnormal according to the future definition of normal. But we picked them because they're apparently normal. Let's start by considering body temperature. We all know, or think we know, that 98.6 is normal and 100.4 is a fever. And we don't stop to consider, well, where did that number come from? And in fact, that number comes from a single study that was done in 1868. And that has been the definition of normal temperature and fever ever since. Exactly the way that we described, is we took a bunch of people, measured it, found a bell curve, said above the 95th or 99th percentile is abnormal. Now, if we get more detailed than that, well, you can see that here in this chart, the normal, healthy adult human has a body temperature that changes over the course of the day. They averaged each individual's body temperature per time of day, and they were able to generate this kind of a curve. So at night when you're sleeping, your body temperature drops by quite a lot. Your body temperature also rises above its average around 5 p.m. and then declines back down. So every individual has a normal variance through the day of nearly 1.5 degrees. Now, if you take all of those temperatures that were measured and ignore the time of day, and instead you just plot those temperatures on a graph, you'll end up with, just as I described, a bell curve. Now, the average temperature in a recent study is actually not 98.6, it's 97.7. We've been seeing worldwide, even in non-industrialized areas, a decline in the average human body temperature has been occurring generation by generation. So we don't have an explanation for that, but we do know that the average body temperature seems to be going down. And some medical societies have raised this as a question: is should we redefine normal body temperature? Should we redefine what a fever is? But another question is, well, if my body temperature average is way out here on the edge of the bell curve at 100 degrees, well, a fever for me shouldn't be until 101. And by contrast, if I'm on the far other side of the bell curve and my average normal body temperature is 96 degrees, well, then even 98.6 should be a fever for me. So there's this interesting question of individualization. And we're going to get into that even more in depth in the next section.